Now that we learned which tools we need and that we also already got some example setups where all those tools were already integrated, or to be precise, where vtest was added, which is both a test runner and an assertion library, or which combines both tools to be precise. Now that we got all of this out of the way, we are going to dive into the basics of unit testing and really automated tests in general in this course section. And for this, we are going to, of course, create some unit tests. We're going to write some unit tests, and you will learn how you write unit tests, how you state your expectations, how you define what a success or a failure of a test is. And you're going to learn all about that. You're also going to learn about a specific pattern which you should use when writing tests, the AAA pattern: arrange, act, and assert. And you're also going to learn what you should test and how you can organize your tests if you're testing multiple things, maybe also for different units. That's all we're going to learn. It's a lot of things we're going to explore, and therefore let's get started. Now, to get started with the basics, I'm back here in this project setup about which I talked at the end of the previous section. You got these three project folders. Again, you find them attached to this lecture in case you skipped the previous section, but I do recommend that you watch it. And then for every project folder, I ran npm install to install all the dependencies. And we got our two backend Node.js projects here and one frontend project. And they all produce the same website in the end with different means, as you learned in the last section. So that's the setup. And how do we now write tests? Well, for this, I'll dive here into the frontend folder, though it really does not matter, because as you will see later, the same tests will work for frontend and backend. It does not matter here, at least for the things we are testing. Later in the course, you will learn about some differences, but for the start, it does not matter. And here in this basic testing frontend folder, we got this app.js file, which holds the starting code, the main entry code that's executed here when the index.html file is loaded. Now we got lots of code in there, and we will get back to this code later in this course, and we will learn what we can do about this code when it comes to testing and how we maybe should improve this code for testing. But for the moment, we'll ignore this code and we'll instead dig into one of the files that gets imported into this code. And to be precise, I want to dive into the math.js file here in the source folder. In this file, I'm exporting one function, the add function, which takes numbers, which seems to be an array of numbers since we're looping through it here. And then we are calculating a sum where we start at 0 and where we add every number that's part of this array to the sum, and then we return the sum in the end. Now, this add function gets used in our code. You can, of course, go through the code to see how it works and what happens there. We are using the add function here in the end after parsing and cleaning and transforming some numbers that were submitted by the user, but that's not too important. Instead, let's focus on this add function, because this add function is our first unit that we want to test. A unit, as you learned, is a small piece in your software that works pretty much standalone, you could say. And very often, your units are functions. It could also be a class maybe, but very often, I would say in the vast majority of cases, your units are functions. And you want to find the smallest pieces really. So for example, in app.js, we also got a function, the form submit handler, where a lot of things are going on. You could call this a unit, but actually the functions that get called inside of these functions are the smaller units. If they weren't, they wouldn't be called in this function. So you want to, in the end, look for functions that are not calling any other functions, you could say, and that are your units. And in the end, your units should be small and not do too many things. But I will also get back to that later. So that's our unit. The add function is the unit we want to test. And what can we test here, or how do we test this? Well, for this, let's first of all add a new file that contains the tests for this function. That's what you typically do. Now, actually, VTest also supports writing your tests in the same file as your main code is. It supports in-source testing, as it's called. And this can be very useful, as you will see later, but for the moment we'll ignore this feature, also because Jest does not have it. Therefore, we'll do something which you will typically do. We'll add a new file, and now very important, we're going to give the file the same name as the main file, which we want to test, but we're going to add .test here in front of the file extension. Alternatively, you could use .spec. That's another common choice. Both works. And if you choose .spec or .test, VTest, once you execute it, will automatically see that this is a testing file that contains tests, and it will execute any tests you write in that file. And the same is true for Jest. So you want to choose math.test.js or math.spec.js, and then your test runners will pick up that file and will execute that file. And VTest is our test runner here, as you learned. And VTest is already installed here in this project, and it is executed if we run the test command. It's actually executed like this, and I'll get back to what these flags mean, but it will be executed. So we got this math test.js file, and now with that file added, we want to add our tests to that file. But how do we do that? Well, to add a test, you use a specific keyword, and the keyword is the test keyword. To be precise, test is a function, and to use it, you should import it from VTest. If you would be using Jest, you could also use the test keyword even without importing it. If you don't want to import it, you can also use the function without importing it by adding a special flag here after VTest and package.json. If you add -- globals, then those key functions like the test function, which I just showed you, are available globally, and you don't need to import them. That can be more convenient, but I will actually not use this, and I will instead import test here instead of having it globally available, because that gives me better auto-completion and support here in the code editor, as you will see. So you can import this test function here from VTest. Alternatively, you can import the it function, which does the same thing. They are synonyms. You can use test or it, and the same is true for Jest. It supports a test function or an it function. Now, it might be a strange name, but it will make more sense in just a second. These functions, test or it, can be executed. Here I'm using the it function. And then, as a first argument, you provide a string. And in that string, you define what your test will test and what your expectation is. And you want to provide a very short, concise sentence that describes this. You don't want to write an essay here. Now we want to execute our tests. And as mentioned before, for this we need to execute the test script in the end, which uses VTest to run our tests. So we can open our terminal here, in VS Code in this case, and in there I will run npm test. You could also run npm run test, but for test and start, you can actually just use npm test. Of course, you also must make sure that you are in the right folder before you do that though. So here I navigated into the folder, and then you can run npm test, and if you do that, all your tests are executed, and you should see an output that looks like this. Now what you see here is in the end a summary where you see that one test file was found, and overall we had one passing test. So we had one overall test, but also one passing test here, so to say. And you also see some output regarding the test file, and then also regarding the exact test that was passed. And you see that it was successful because you have that green check mark here for the overall file, but also for one specific test. And the text you see here is, of course, the text you defined here. So this is how these things are related, and choosing a meaningful text here, of course, makes sure that the output is a bit easier to understand. It does not matter if you just have one test, but if you have multiple tests, this will of course matter at some point. Now, as a side note, in package.json for the test script, if you remove reporter verbose and you just have -- run, then what you get is a more simplified output, because then you just get the summary and the test file that passed, but you don't learn which tests did pass, so you don't get the detailed test output. I like that detailed output, but you can remove it simply by adding or removing this flag here. The -- run flag means that it's only executed once, and the alternative is that you keep watching your test files. For example, here I added another script to show you what happens if you just run a vtest without flags. If you run npm run test:watch, you enter this watch mode, and now it also executes the tests, but it keeps watching our test files. Just as we could run a development server during development, which watches our source code files and therefore also reloads a page if we change our source code. Now the test files get watched. And this means that if I now change something in a test, for example, my expected result, if I change it to 5, and I then save this, it automatically re-executes the test, and it now also failed. And we can see here that we failed. We see which test failed. You see that even if the mode is not set to verbose, because you want to learn which test failed. You see that this test failed because we have this red cross here. And we see which line caused the test to fail, what the expected value was, and what the actual value was that we got. So we learn why the test failed. And then we see the summary that 1 of 1 tests failed in the end. Now, of course, here I will fix this by switching back to 6, but it is important to understand what watch mode is and what failing tests look like. And this also already therefore shows you how you define when a test is considered successful and when it is considered a failure. It's successful if your expectation is met, the expectation you define with the expect function and then one of these two functions, and it fails if the expectation is not met. That's how easy it is, and that's our first test, and that's how unit testing works in general. I'm now going to quit this watch mode here, but you can of course also keep it enabled. Now we did add this first test in the previous lecture, but why exactly are we writing such tests? I mean, it's clear to us that this function works. Well, the idea is that we add more and more tests over time. We can then easily run them all at once to check if our entire project works, instead of performing a bunch of manual tests. But of course, we might be confident that everything works initially, though you shouldn't be too confident. You might have bugs in your code, and your tests could help you catch those bugs as you're writing your tests. We'll see more examples for that later in this course. But even if your code, your production code, your main code is error-free right now, tests are still valuable. Because we defined our test here, and this test describes the expected behavior of this add function. Now let's say a colleague, or maybe ourselves in a couple of months, comes back to this add function and changes something there. For whatever reason, we decide that this is not the appropriate way of doing it, and we get rid of the initial value of 0 here. It's a tiny change, but it is a change. Now, if we have automated tests defined as we do, then whenever we make changes to our code, we should run our tests again to see if we broke something. And if we did break something, we might want to check if that was intended, because that, of course, is also sometimes the case. Sometimes failing tests are okay because you have an intended change that should be breaking. But here we would run npm test, and we would see that now our test fails because we expected a result of 6, but we got not a number. And we're getting not a number, of course, because we changed this to undefined initially, and when we add numbers to undefined, the result is not a number that makes sense, but it's this special JavaScript not a number value, because undefined plus 1 is not a number. That's how JavaScript behaves, and our test helps us quickly catch this error. And that's one of the main reasons for writing such automated tests. It makes it easy to check your code when changes to that code are made, and then you can evaluate whether that was an intended change if things break, as mentioned before, or, like in this case, it maybe is a bug that was now introduced. Of course, you could also catch this when testing everything manually, but it might take you longer. You might not test this functionality specifically, and therefore you could introduce subtle bugs without recognizing if you wrote tests and you have good test coverage. So you try to cover all your functions, all your units, and all the key functionalities and scenarios, then you can quickly catch such unintended changes and bugs. Now, to get started, we could simply write a test that should test the main thing this function should do, this add function. It should sum up all the numbers in an array of numbers that's passed into this function, and it should then return the sum. So we could write here, it should summarize all number values in an array, something like this. Now you also see why the it function exists, because now this reads like a nice sentence. It should summarize all number values in an array. That's why it's called it. Now this reads like a nice sentence. If you would have used test instead, then it reads test should summarize all number values, which also isn't too bad, but I prefer it also because many other test runners use this function instead of test. But ultimately it's up to you. So here we have this it function which we execute, to which we pass the description of our test. The description is of course nice, but what's missing is the actual test. And that's the second argument you pass to this function, to the it function. Here you pass a pointer to another function, or you just create an anonymous function in place, for example an anonymous arrow function, and in the body of this function you will write your actual testing code. And this testing code is now, of course, the interesting part. Now, this function will be executed when you run the test. So your test runner will see this function and execute it for you, or it will execute this function for you, to be precise, because with the it function, we register this test and it will be picked up by the test runner. But right now, this inner function isn't doing anything. Now, what should it be doing, though? Well, it should, in the end, execute the add function, pass in an array of numbers, and then define some expected value, which then will be checked by vtest, so by the assertion library you're using. And vtest, as you learned, is both test runner and assertion library in the end. It combines both. And then it will either mark the test as successful if your expectation was met, or as a failed test if it was not met. So here we could, for example, say that we want to execute the add function. And for this, you need to import add from the math.js file. And one tiny note here, if you're using native ES modules without any transpiler or without any build tool like Webpack, then in your main code, you have to add the file extension in your import statements. That's how ECMAScript modules work if you're not having any special tool like Webpack that's getting rid of that in the end. In most projects, you might be used to not adding these file extensions. You actually do need to do it if you don't have an extra build tool. Now, vtest acts kind of like such a build tool, and therefore there you can omit the file extension. I'm just mentioning this here to avoid confusion. But now we're importing the add function, and we can execute it here in our test function, because we want to test the add function here. We're testing the math file, and there we want to test this add function, which is the unit we want to test. So we execute it here, and we pass an array of numbers to it. Let's say an array that contains 1, 2, and 3. The three numbers 1, 2, and 3. And what we get back is the result, because that is what we expect to happen, and we know that this is, of course, also what our add function does. Now we have the result. Now we want to define our expectation, what we expect this result to be, and what we would consider a success. And for this, for defining such expectation, there is another function exposed by vtest, the expect function. And for jest, it's the same. There you can also use the expect function, and you can also use it in the same way because VTest and jest are compatible regarding that, as you can also learn on the VTest site. There they are mentioning that they have this jest expect compatible API, so you can use expect and everything that's related to it just as you could use it with jest. So here we can then execute this expect function, and to the expect function we pass the result we derived in our test. So in this case, the result constant, which holds the result that was produced by calling add with that array. Now, on the result of calling expect, you call another method. So you chain a method call here on expect, and that is now a method that typically starts with to, and then there are many methods that start with that name. All these methods are provided by VTest, or by the assertion library used under the hood, to be precise. And if you take a look at these method names, they in the end all are pretty clear regarding their naming, I would say. They in the end all allow you to define your expectation or your success criteria, to be precise. For example, here we could say that we expect the result, which we got, to be 6 in this case, right? Because we have 1, 2, 3. If we add all these numbers up, we would expect that to be 6. So we expect result to be 6. This is how this can be read. And if you take another look here at all these methods, you see that there are many things you can check. You can check whether it's maybe not a number, if it's null, if it's truthy, if it's a string, if it contains a certain substring, if it's greater or smaller than another number. There are many things you can check, basically all the use cases you could ever want. You can also learn more about all these different to functions if you go to VTest API, and there under expect you find all these different functions, and if you click on one you get a more detailed explanation and also an example. So that's very useful, and you should definitely use this resource to learn more about it, because we're not going to see all these functions in action in this course, but we'll see quite a lot of important ones. So now we expect this to be 6. That is our first test. It's a simple, basic test, and I can already say that your tests should be simple and basic, but it is a test.